You're watching To Marvelous Bob, and in this episode I'm going to talk about application development paging approaches. Every application that is serious enough that achieves even a partial success, and especially if it achieves big size, big scale data or social reach, every such application needs to show to the users some chunk of the information, some big quantity of some data type. Doing this at once at, at that point when the application scales up is impractical and even impossible. Many times even the servers could get overwhelmed if the applications are not coded properly, and let alone some end user with a desktop or a mobile device. To resolve this, paging has been born. Paging itself is just a concept that has a lot of user experience and source code design pattern variations and approaches that adds also several layers and levels of complexity and parameterizations and logic in several layers and so on. And I don't think I could list them all, but I'll describe some of them here in this episode. First, double database layer paging. All self-respecting database systems, relational, non-relational, whatever that is not a just single file, have some way, some instruction, some procedure to page the data so to not flood the other layers, the application or whatever other layer. If you dive deep in the technology you have chosen, in the data storage technology, you probably find the way that this technology pages data. And if some technology doesn't support paging functionality, it should be a red alert for you about the technology. Okay, next is model and data access layer that is in the code, in the application code, and maybe even in the service layer. In most cases, paging could be implemented with page size, an input value, and offset the number of records from where to start, or page number, the page from where to start. This input value again, and the output value is list of records that is one maximum the page size big. This is output value, and the total number of records in the database, or total pages count. So the page size could be small number. The bulk of information could be and probably is some small number, but the offset from where to start should support very big number, especially if you have chosen not pages but a number of records offset. If you plan to show to the users the last pages of some data type that has million records, this parameter should be big int, long in Java, or integer 64-bit, and so on, big. It requires big offset. Okay, so passing around these two numbers may make the APIs more hard to modify and change in the future. So for this issue, a search object is often used and passed as parameters between the data code layers. For this, besides the basic paging stuff that could be set in this object. This object could also contain sorting fields, direction of the sorting, query parameters, and actually whatever you like, you could add it in the search object. And adding this new query parameters, filters, or whatever to this object will require change in the data access layer. It will require changes in the setting of this fields layer, like controller, but it will not require changing of the APIs in between in the service, and maybe in several other, like view model, and in several layers will not require additional changes if search object is used. Controller and front end layers, display layers. No matter on what platform, on what display, on what type of service, even non-user interface service, even if the consumer is not a user interface platform, putting out the whole, dumping out the database is many times impractical, and somewhere, one of these functionalities are used. I will describe them in user interface terms, but they are similar to if code as REST endpoints. So first, previous, next, last. 4 buttons for jumping to the basic, to the beginning, to the next page, to the previous page, and to the end. If the currently viewed page is first or last, or there are too few records, these buttons could be missing or disabled. Second type of paging is with numbers. The 4 previous buttons are not very data descriptive, so in the most normal way is to have numbers for paging, and you could have, for example, odd numbers displayed with one read only, the currently viewed page. So another way of paging is with letters. It is less common, and when the records with some letter become bigger than the page size, letter repetition must be used with similar to the numbers approach. But actually, one service that uses letters for paging is Google. Google uses an endless O for paging, so it is an option. Load more buttons. For loading next page after the end of the display is reached, and it appends more items to the view layer. And this approach could be sometimes a little bit annoying if the end user wants to go to some deeper page. And for the reloading from the beginning, a Puto Refresh concept is often used. It restarts the data view from the beginning. This approach is very used with mobile in the mobile world to reload the records from the first page with the most recent. So automatic page load. This is an additional automatic variation of the option load more button. It is also called lazy loading, and there are 2 technical or architectural options when implementing it. Lazy loading append. It is the same as load more button. It appends to the visual or data layer the newly downloaded records, and letting the service draw the scroll. And this approach could create slowness on the client if the records become too many. And the other option is lazy loading with a virtual scroll. To resolve the problem of overloading data, many user interface frameworks have implemented virtual scroll partially in the presentation layer or even entirely in the data layer also. So the land don't get blown up by too many records. On whatever screen, the number of records that can be displayed is limited, and having more instances of some visual component like HTML div, like iOS, Android view, like desktop widget, or whatever component for displaying data you use, it is a waste of memory and a placeholder for bad performance if you load a lot of instances of these UI components. And because the scroll itself is actually a visual element, it could be also tweaked and painted by the visual frameworks according to the total number of records and not the amount of the loaded records in the client layer. And this will achieve full pageability. Such a concept I have seen in Android architectural components, and partial pageability is implemented with the Android adapter class and the more recent recycle view. And the same concept is also found in Angular and in Vue.js and several other frameworks. It is paging, displaying the scroll depending on the number of records, and this is partial pageability. Full pageability is having the total count of records and painting the scroll accordingly, and when the viewport changes, it reloads the records, and if it takes time to reload these records, a loading component with the same visual structure is often used. This concept I have seen in YouTube, for example. So this is for today. See you next time.